Hitomi Taguchi, and I am a PhD in chemical engineering. Today, we have a question from Andrea at Sherman Elementary School, and her question is, what are bubbles? Great question. So when she said, what are bubbles? The first bubble that came to mind are those liquid bubbles. So when you have a liquid soap solution, you dip a straw inside and you blow into it, the stuff that comes out, that's what I thought of. So what are they? What are those bubbles that you're seeing? Well, if you actually have a liquid solution and you have a straw, you might want to just watch carefully how people are doing it. They first dip the straw in the solution. Look at what you see on the end. You'd probably find a very thin film of liquid soap that is coating the opening of this end. So when that person, your friend maybe, blows into that straw, watch carefully what's happening at the end. You will see that the liquid film that was coating this end is slowly becoming bigger and bigger. It's stretching because of the air that is coming from the body through the straw into that film. The air is pushing that liquid film, and as a result, it's forming that thin liquid film of soap water is being stretched into the bubble. So Andrea, long story short, a bubble is basically a balloon where instead of a rubber, it's a liquid soap solution that is surrounding the air that came out of your body.
Hi there, my name's Eric, and today I'll be trying to answer the question, how do atoms work? This awesome question was brought to us by Esteban from America's Greatest Charter School. Actually, this is such a good question that people have been thinking about it for thousands of years. One of the first people to start asking about atoms was an ancient Greek philosopher named Democritus. He was born all the way back in the year 460 BC. Now, that's an awfully long time ago, considering it would be thousands of years before scientists would begin to confirm the existence of anything like an atom. To see why people like Democritus might have believed in atoms, even though they hadn't been observed yet, let's think about what happens when we split something in half, like, say, this statue. Okay, well, nothing too exciting happens. You just get two halves of the statue. And you can even do this kind of thing again. But this begins to beg the question, could we continue splitting the statue in half forever? Well, Democritus and his fellow atomists didn't think so at any rate. They believed that the infinite divisibility of matter would lead to paradoxes. So they reasoned that all matter must be made of small building blocks that can't be split into smaller parts. They called these things atoms. It wasn't until the 1800s that a line of experiments began to confirm the existence of atoms. These began with an early chemist named John Dalton, who studied what happens when you put different kinds of matter together. He reasoned that all matter must be made of small building blocks, which he called atoms. He imagined these atoms to be simple spheres, but this picture was quickly updated by a man named J.J. Thomson, who realized that atoms could actually be broken into different parts. Some negatively charged electrons and positively charged protons. Soon after this, a man named Ernest Rutherford discovered that atoms are not just a simple mixture of the negative electrons and positive protons, but the positively charged protons actually form a dense inner core inside the atom, which we now call the nucleus. With the discovery of a third uncharged particle called a neutron, that hangs out in the nucleus with the protons, it seems that scientists had finally answered the question, what would you find if you decided to split a statue in half over and over and over again? What you'd find are atoms. Now that we have some idea about what atoms are, we can begin to answer the question, how do atoms work? Now, when I hear the question, how do atoms work, what I think is, what holds an atom together? For instance, why do the electrons orbit around the nucleus instead of, say, well, just fly off into space? To answer this sort of question, scientists had to posit the existence of something called electric charge. Now, I've already mentioned electric charge a couple of times, but couldn't really be bothered to explain what it is. Electric charge comes in two types, positive and its opposite, negative. Now, if I bring two opposite charges together, a positive and a negative, they'll be attracted to each other, meaning that the positive charge will pull the negative charge towards it, and the negative charge will pull the positive charge towards it. But if I have two similar charges, such as a negative charge and another negative charge, or a positive charge and another positive charge, these similar charges will push each other away. They'll repel each other. With this idea of electric charge, we can now begin to understand why the electrons don't just fly away. The negatively charged electrons are always being pulled towards the positively charged protons. But you might be thinking, what about this thing called the nucleus? What holds that together? The protons are both positively charged, so shouldn't they want to push each other apart? And what about these neutrons? What's holding them in place to begin with? To explain what holds the nucleus together, scientists had to hypothesize the existence of another force which they called the strong force. They called it this because, well, it's so strong. With the addition of the strong force, we finally have an understanding of what holds an atom together. The opposite electric charge of the electrons and the protons pulls the electrons towards the protons and keeps them from flying away, while the strong force holds the protons and neutrons together inside the dense nucleus. But are these really the atoms that we set out to find thousands and thousands of years ago, beginning with Democritus? Oh yeah, hey, remember Democritus? He thought that all atoms were indivisible particles, meaning they couldn't be broken into smaller parts. But we already know that atoms can be broken into protons, neutrons, and electrons. These sure don't sound like the kinds of atoms that Democritus had in mind. If that wasn't strange enough, it turns out that the protons and the neutrons can also be broken into smaller particles called quarks. In fact, scientists have discovered a whole bunch of other particles since the discovery of the atom, including the up and down quarks that make up the protons and the neutrons, and let's not forget about our friend the electron. By the way, for those of you wondering if any of this is actually useful, the answer turns out to be a resounding yes. For example, harnessing the flow of electrons into an electric current has given rise to the field of electronics, which is certainly an important part of everyday 21st century life. The study of what happens when the electrons in different atoms interact is now known as the field of chemistry, which, to say the least, is an important part of things like medicine and fuel, which provides the energy that makes your car go. Also, since the strong force is so darn strong, it turns out there's an enormous amount of energy in the nucleus. This leads to things like nuclear fusion, which is the process that keeps the sun burning, and in turn, provides all energy for life on Earth. But this is a lot more than I have time to talk about in one video. So at this point, I'd like to thank you all for watching, and once again, thank Esteban for such an engaging question.